Ears ringing yet, folks? The engine history is on shift. Any old-school mechanic who hears high-pressure steam hissing and punching through a leaking joint knows instantly how brutal this cast iron beast really is. This Atlas automatic machine was built in 1890. Waking up a multi-ton chunk of cast iron after more than a century of rust and neglect is not as simple as tossing wood into the firebox and boiling water. The crew has to keep a hard eye on the pressure gauge. They have to tap test the boiler shell with a hammer. They have to manage every high-pressure oiling line with discipline. One mistake, and you do not just lose the run, you can blow the whole shop apart. Today, we roll up our sleeves, we light it off under load, and we run this steam giant on the test stand to measure it in real life. The Atlas Foundry guys in America built a blueprint that looks freakish, but it works. They ditched the bulky centrifugal ball governor that usually hangs outside in the open. Instead, the engineers packed the springs and flyweight mechanism deep inside the flywheel hub to keep dirt out. When a sudden load hits while it is running, that hidden mechanism snaps and shifts the eccentric cam timing. It locks the RPM down fast. So the sprockets and chain drive behind it do not lose rhythm and fall flat. If you love the smell of metal filings and you want to see real vintage mechanical specs, hit subscribe on the engine history. Turn on the notification bell too. Your subscriptions are the pressure that keeps the team fueled to hunt down these expensive old cast iron relics and bring them back for teardown, fabrication, and hard load testing. The rust is scrubbed off. Every shaft and journal is exposed. Now comes the job of forcing oil into the bearings. Before high-pressure steam tears into the cylinder and rips a dry oil film apart, the mechanic has to pack high-temperature grease and flood the rocker gear with oil. Firewood smoke mixes with heavy oil vapor and turns the whole shop into a burnt, greasy haze.
There's a little steam engine out here, and it drives the...
Goes across that pipe right there. Well, how do you get the steam, I guess? How does the...
Look at those bright brass oil cups sunk into the cylinder head. Drop by drop, thick black oil goes in, and the crew has to keep boiler heat strong, so the oil thins, flows, and creeps into every clearance of the slide valve gear. On this machine, lubrication is life or death. It is the shield that stands between metal and hundreds of PSI that want to scrape the bore raw.
Well, you want to keep her in the sight glass. You got a problem.
The height of this water.
Okay.
It goes down like it's getting the ability of it blowing up is very, very...
The moment the mechanic cracks the main steam valve is when your brain has to stay sharp. That is the moment where one slip can cost real money. The white plume blasting out of the bottom drain is not steam. It is a pooled liquid condensate. If you are slow and you do not drain it completely, water hammer can slam back like a hydraulic punch and shatter cast iron instantly.
Well, I take it home to my house down there.
Okay. Do you take it to shows or anything?
Nope.
So, Jim, do you know how many approximately of these are still...
Heat blasts straight into your face and sweat pops out fast. Pressure hisses past rotted flange gaskets and bites into your ears. A skilled operator has to use bare hands slick with grease to control the flywheel momentum.
Talk about this
They listen for the exact deadly tolerance window where piston travel and slide valve timing stays safe.
And it turns that way. This is just like the motor in your car. This is the... It'll go to that. Now we got it going.
Now swing the camera over to the D-shaped slide valve clamped tight along the engine side. This is the mechanical lung that decides whether the Atlas steam setup comes alive or falls on its face. An eccentric cam mounted on the crankshaft yanks the linkage and drives the slide valve back and forth. That motion directs high-pressure steam into the cylinder at the right moment. During prep, the mechanic has to pull out feeler gauges and measure every hair of clearance. They set the valve lap. They set the early admission lead. If you set it too early by even a tiny amount, compressed steam can kick back and smash the piston face. If you set it too late, the engine runs out of breath and cannot carry the load. The slide valve face scrubs hard against cast iron under massive pressure with no bearing help at all. That brutal contact shows just how good the hand-era milling and machining really were. Throwing a century-old cold cast iron machine into steam heat is a savage test of thermal expansion and fatigue. When hundreds of degrees of steam slam into the combustion space and metal walls, the whole block starts to grow. Old hands have to calculate that expansion from the beginning, back when they fit liners, pins, and bearing shells at room temperature. Set the bronze bearing clearance too tight, and once the engine heats up and expands, the entire shaft train can seize, and you can spin bearings or throw a rod. Set it too loose, and the shaft will knock violently and beat the mechanism to pieces. The real toughness of this workhorse lives in the mechanic's hands on the bearing scrape and fit. It also lives in the mechanic's mindset on measuring and respecting material expansion. Now the engine catches its expansion rhythm and starts throwing exhaust back out. That massive, solid cast flywheel spins hard on stored inertia. It swallows the steam shovels and turns them into a violent band of torque through the crankshaft, enough to twist a drive chain apart. Oil flings off the rods and linkages and sticks to peeling paint, exposing scars that measure tens of thousands of hard-working hours. This Atlas setup throws electronics in the trash. No fragile boards, no sensors that panic the moment water gets near a connector. It has survived across 2 centuries on firewood heat, boiler feed water, and the hand skill of mechanics who scrape, fit, and set clearances the old way. It growls like a challenge to the hardest load limits you can throw at it. Today's firing and heat up of this hand-cast Atlas power unit locks in one hard truth. Old one-piece cast iron machines were built to plow and pull and to wring every brutal ounce of expansion force out of steam pressure, not to be delicate. Thanks for staying with the engine history through the smoke, the grease, and the burnt oil smell while we held tolerances on this beast. From a teardown mechanic's viewpoint, what do you respect more? The ear-splitting pressure hiss or the hidden flywheel governor tolerances? Drop your technical take in the comments so the shop crew can keep digging. See you in the next round of fabrication, assembly, and load testing.